do the
Will do.
And good evening, live from Charlotte. I'm James Brierton. This is the Carolina Weather Group. Coming up, we're going to be talking about the NASA INPACTS project, which fits into the theme of this week. Winter is finally arriving here in the Carolinas, and we're going to be talking to a special NASA project about how they are storm chasing these winter storms, including the one here in the Carolinas tomorrow, to better understand the behavior of winter storms and to get a more accurate intensity forecast. All that coming up in about 10 minutes. But as you can see right now, scrolling on the side of your screen, we are in winter weather mode here at the Carolina Weather Group with a threat of winter weather across a good portion of the Carolinas tomorrow. If you're joining us from the North Carolina areas shaded in purple here, you have a winter weather advisory that goes into effect tomorrow and rides through all day tomorrow. And this actually also includes a few counties in South Carolina, such as York or Lancaster or Chesterfield. And then if you're joining us from eastern North Carolina, there in blue, that is a winter weather watch. What can we expect with this storm, and what has prompted the National Weather Service to go ahead and issue those bulletins and advisories? Well, it is going to possibly be the first measurable snowfall for a lot of us outside of the western North Carolina mountains. You can see here the outlook and the forecast from the National Weather Service in Greenville, Spartanburg, calling for maybe up to 2 inches in some of the higher elevations, maybe up to about an inch or so in Charlotte. But I would say there's still several scenarios that are on the table here, and it all depends on those temperatures. You've heard us talk about them so often here on the Carolina Weather Group, and you often refer to it as that warm nose. So we will have precipitation rolling in, at least from the Charlotte perspective here, at about noon tomorrow, starting as rain, and then when temperatures get just cold enough as we go on through that afternoon hour, we do expect that to turn over to snow. How soon does it turn over to snow will determine those accumulations. On the lower side of things, where we're just warm enough, long enough, we could end up with just a trace amount of snow accumulations here in the Queen City, but maybe upwards of about 3 inches if we get that change over to snow a little bit earlier on. Let's go to Scotty Powell. He's joining us from Morganton, where the National Weather Service is calling for about 2 inches of snow. But Scotty, there's a couple scenarios there where you guys could see some more snow than that too.
You are doing well, and I hope you're prepared for what looks to be our first winter weather event, major winter weather event. Yeah, we're looking at my forecast is actually a little bit higher than that, 2 to 4 inches of snow across the Interstate 40 corridor from, let's say, McDowell County all the way through Statesville up into the Piedmont Triad area. Looks like that we could be on that northern fringe of where the transition zone between snow, sleet, rain is at. Normally, right north of that line is normally what we call a deformation band. And I think portions of the foothills and the Interstate 40 corridor could find themselves underneath that band. So I've upped the forecast a little bit from 2 to 4 inches of snow, especially along like Burke, Catawba, Alexander, Iredell County areas. I feel like that zone could really cash in, and just from experience and history, similar setups with these storms, it seems like they always overachieve here in the foothills. So I'm a little bit higher than that, but again, 2 inches still a good bet here in the foothills. So a lot of area schools are already closed or dismissing
Right.
early for tomorrow. So everyone is getting prepared. I will say, interestingly enough, though, DOT has not prepared any of the roadways. I know there's some concern with maybe the initial start of this precipitation being rain or rain-snow mix. So none of the roadways are prepared up here. So if it is a little bit colder and it starts off a little bit snowier, we could see some travel concerns here along the Interstate 40 corridor, James.
Yeah, and in speaking with them today, the reason they haven't done that is because if they were to put salt or brine down today or tomorrow morning, it's going to get washed away by the rain that is the prelude to this event. So it's not that they're slacking, but they've got plenty of salt. we know they haven't really had too many opportunities to use it up until this point, but they are preparing. So you heard Scotty there talking about a forecast for maybe. Go ahead, Scotty.
Yeah, and James, one other thing I was going to tell you, this is kind of a nowcasting situation. I was just outside a little bit ago before the show started to take my dog out, and the skies are clear here, and it's pretty chilly. We're already down into the upper 30s, so the forecast of the low was supposed to be around 39, 38 degrees. We're already there, and with clear sky the next few hours, we could see those temperatures drop a little bit colder than what was forecasted. So that just brings more interest to what the weather will bring us tomorrow.
Yep, working on bringing up a live picture here from resort camps looking in Boone tonight. It is quiet, it is clear, and as Scotty said, it very much will be a now casting situation. I wanted to pop up before we leave the western North Carolina region, the official forecast outlook from the National Weather Service. Again, calling for maybe about 2 inches in Boone. That could be on the conservative side, exactly depending on how this plays out. But right there on the fringe of this map, which shows you that forecast area for the Roanoke Blacksburg market, you can begin to see how numbers begin to creep back up actually as you make your way east across North Carolina, about 2 inches there in Reidsville. And I want to show you this map from the North Carolina Raleigh office of the National Weather Service, where Raleigh could be seeing at least about 3 inches of snow. So again, this is actually a scenario where not only will the mountains be seeing higher amounts of snow, but actually across western North Carolina as well, where we have that winter storm watch in effect. And that's kind of where this bullseye may set up as we shift this map even a little bit further to the east. Now Elizabeth City, 3 inches or so could be expected, and even some snow up into the Virginia Beach area. Let's just pop up a few more of these maps before we bring in the rest of our panelists and show you what the rest of the region is. It could be expecting, again, maybe about 2 inches here, tapers off as you make your way towards the coast, but we are going to be seeing snowfall accumulation along that I-95 corridor. And so for the most part, this is an event that is going to be affecting a lot of primarily North Carolina. But as I mentioned, we do have that winter weather advisory out even for a few counties in South Carolina, such as Lancaster here and Chesterfield, where we could see maybe upwards of an inch. So again, as Scotty's been talking about, there are different scenarios that could play out here, and it's possible that the forecast maps, if you are of the opinion, may be a little bit on the conservative side of this scenario. But again, like so many of the snow events we see here in the North Carolina, it's really, really tricky because it's one thing to put a forecast out to talk about how much rainfall accumulation we're going to get, and it's another to talk about how much snowfall accumulation we're going to get. When we're talking about that frozen precipitation, even the slightest changes become that much more sensitive in the forecast. So it really will be very much a now casting situation. Before we get over to our NASA Impacts interview, let's bring in Evan Fisher, who's joining us tonight from Charleston, South Carolina, but he also resides a lot in Asheville, and I know he's watching it from both those perspectives. So good evening to you, Evan.
Good evening, James. So I would kind of mirror a lot of what Scotty said for the Western North Carolina region, Asheville up into Boone. We're looking at generally 2 to 4 inches, unless you were in the Balsams and or kind of the Highlands area. You might get lucky and see more like 4 to 6 inches. Unfortunately, the snow is going to be starting around rush hour on Thursday morning, so it's not the best of timings. Although luckily, the roads are a little bit warm right now, and it's going to take some heavy snow in order to overcome that temperature and start to stick. So if we're lucky, we'll get through the morning rush hour without any major problems. However, looking later into the evening as snow is tapering off for the evening rush hour, as well as Friday morning, there could be, honestly, we could be looking at some serious refreezing issues. And if roads aren't treated and, there's rain initially and then snow falls and then melts a little bit in the day on the roads, they're all going to refreeze overnight. And that's going to cause some serious travel issues, not just in West North Carolina, but across the state into Charlotte and Raleigh and eastward.
Yeah, what I want to do now is I want to show this to everyone at home on one of our model runs here. So we are currently getting in the latest and greatest model run for the NAM, and we could expect to have that over the next hour or so. So before you go to bed tonight, if you're going to be, watching your late local news, you may see the latest NAM run come into that broadcast. It's currently compiling. So this is the one from a few hours ago, and this is one of those forecast models that we talk about. So you can see here as we head in through the overnight, still relative to some of those blues, the snow across across the foothills and the mountains of western North Carolina. A little bit of mixing and sleet as you make your way from foothills down into the Charlotte area, and that sleet is going to also really affect the accumulations forecast on whether it's a boom or a bust, depending on how long we stay kind of in that intermediate between the rain and the snow. And then you can see we do turn to all snow as we get towards that very critical evening rush, and then the snow will wind down from east to west as we go through the overnight hours. And as Evan just mentioned, we can expect whatever is still left on the ground to refreeze and become quite an icy commute Friday morning. So this is going to be an event. Not only will you want to pack accordingly as you head out the door tomorrow, but also plan ahead for your workday on Friday. Before we move on to our interview for tonight, I want to give any of our panelists another opportunity to weigh in on the snow. I don't know if Scotty Powell or Shay Gibson had any other thoughts they wanted to throw in before we get on to tonight's interview.
I think a good point is if you wake up tomorrow morning and it's not snowing, don't freak out. It's going to be an all-day process starting in the west and then move into the east. I do believe wholeheartedly that someone's going to end up tomorrow evening with a big surprise, and I'm talking about a bigger snowfall too. I don't know where that's going to be at. It's still up in the air, but I do believe there's going to be a few folks who are going to be surprised by how much snow they get. Shay, I was looking at that last model, and I'll toss it off to you before we get to our interview. It looks like it could be quite windy along the coastline as this storm really cranks up off the southeast coast.
Yeah, that's right. This cold air that's diving down behind the cold front, it's really driven by a large ridge out west. And really, we have to kind of think of the dynamics. Right now, we have the subtropical jet stream overhead. And normally, when we start to push snow south of this cold front, folks down here in Charleston are asking about snow. Well, usually you would expect the northwest flow with a strong or a solid cold column to follow it with any moisture left over with just a few flakes. This case, we have more of a westerly flow at the mid to upper levels, according to the latest soundings. And so when you start mixing in northeast winds, you get warm nosing along the coast, which just means cold rain. If a few small flakes were to follow, I wouldn't be totally surprised, but it's a very low chance. We're talking 4% on the Schreff Flume Viewer. The NAM model has a quick little dusting possibly, and that usually would occur a little bit further north of us where the north winds are pushing down. So the surface winds will be more north to northeast and then aloft more west. So we don't have a solid northwest column really pushing that down. But, dynamics can change because low pressure, wherever the low pressure tracks may depend on whether or not we see anything along the backside, especially Myrtle Beach area should be watching that as well. But eastern North Carolina, I'd be a little concerned about some sleet just because of northeast winds at the surface. Again, anytime you get an easterly element to that can throw off the snow amounts and actually add more of an icing effect. So that'd be my concern for eastern North Carolina. But as far as South Carolina, I think most of northern South Carolina, all the way over to the PD area, is probably going to see the highest chances for snow. And further south, if there's a quick little flurry dusting before sunrise, there's a possibility for that too. So I'm not ruling it out, but it's not going to stick, and it's nothing to worry about on the roadways.
All right, gentlemen, I appreciate that very much, and thank you for everyone checking in on our special snow forecast coverage tonight. As Scotty mentioned, this very much does become a nowcasting situation, so you can be sure to check back in here at the Carolina Weather Group tomorrow and throughout the day for the latest on that. And be careful as you head out the door tomorrow morning and plan ahead, because as you head out the door tomorrow morning, you need to be thinking about that drive home and then that drive back to work the following day. We will continue to scroll tonight the latest winter weather advisories, winter storm watches, and even still some of those remnant flood warnings on the side of your screen tonight as we join our scheduled interview all about the NASA Impacts Project, which again is studying and chasing winter storms just like the one here in the Carolinas. They will be out and surveying tomorrow's storm to gather all sorts of very sensitive data that will help us better forecast the intensity of these storms. And I'm going to stop talking and get right on over to tonight's interview because they explain it a heck of a lot better than I do.
Hello, everyone. Welcome to the Carolina Weather Group. We welcome you to our latest edition of our little podcast, Weather Live Stream. And we're going to be talking about an interesting project tonight, the Snow Impact Project. You may have heard about this project just recently released out on social media. NOAA and NASA and a lot of different entities working on better forecasting winter storms, and especially along the East Coast here where we live, that will be helpful because we know a variation in just a few miles can mean all the difference in snowfall forecasting. Tonight we have with us Lynn McMurdy. She's kind of leading up this research project. She is a associate professor at the Department of Atmospheric Science from the University of Washington. So, you know, last year on our 300 show, we were talking about the states that we've not had guests from. So we can mark Washington off that list. So now we're down to, I think, 6 states that we've not had any guests from. So, Lynn, welcome to the show tonight. Definitely happy to have you. And I know it's a busy time as we're in the midst of this research project. So tell us a little bit about the project and maybe how it got us started and how you guys came together to get this idea and get the ball rolling, per se.
Sure, happy to do that. I'm excited to be able to tell you all about it. So as you know, being a NASA project, our name of our project is an acronym because everything is acronyms with NASA. And the name is called IMPACTS, and it stands for the Investigation of Microphysics and Precipitation for Atlantic Coast Threatening Snowstorms. So in its name, it tells you a little bit about what we're doing. So I'm leading this project with I don't even know how many people I'm working with, probably hundreds. It's funded by NASA. It's a very large program that's a 5-year project. And the middle 3 years we'll be doing gathering data and gathering cases to study. And it's part of their Earth Venture Suborbital call for projects. And this means instead of NASA funding somebody's idea about satellites, this is using aircraft. So suborbital means below the orbit of the Earth. So the main way that we are performing our investigation is through aircraft observations. So what we're trying to do is, as you well know, snowstorms, which occur all winter in this part of the country, are pretty difficult to forecast. They're fairly complex systems. They consist of large cloud shields that can be as far as Florida, way up into Canada. And within those big complex cloud parts of the storm, there's narrow bands of more intense snowfall. We call them snow bands. And it's that those smaller scale features, usually near the low center of the storm itself, that we are specifically trying to investigate. We're trying to understand the processes that form the snow bands, that make how they change as a storm evolves, and why some storms have a lot of snow bands and others have like absolutely none, yet they both are producing snow. So that's kind of the science focus of it. And our observational strategy involves primarily 2 aircraft. One of them will fly high above the clouds. It's NASA's ER2. It can fly at 20 kilometers elevation, which is 68,000 feet, or twice as high as a commercial aircraft. And it has equipped with remote sensing instrumentation. So everybody's probably familiar with weather radars. This airplane has 4 different radars, all different wavelengths. So they're sensitive to different portions of the storm. There's one that's a cloud radar, so it can see the small cloud size drops, and others are more rain and snow radars. They see the bigger drops. It also has microwave radiometers, and those are types of instruments that we often fly on satellites to measure precipitation from space. So that ER2 flies above the clouds way up high and looking at the storm remotely, and then underneath in coordination, observing the same portion of the storm, is the NASA's P3 Orion, and it flies inside the clouds, and it has a multitude of instrumentation, and the major ones are these cloud and precipitation probes, which actually essentially take pictures and count the sizes and the pictures of the snowflakes as they form. We fly it at different levels to see where the beautiful dendrites form, where the needles form, and then fly underneath, and they aggregate into large, big blobs of snow that eventually falls on the ground. We also have some ground instrumentation specifically for this project, and that includes a whole array of different radars and other snow measuring equipment, mostly on Long Island with my colleagues at Stony Brook. So one of the things you asked me to mention is like who's involved. So obviously I have a large crew of people involved with NASA, but the National Weather Service is also involved. They are sending up extra Raywin sondes, so we measure the profile of the atmosphere more frequently during these snowstorms. We just request them to, can you please put up some more at Albany and at their usual places. They'll add more Raywin sonde launches when we're flying, at the time periods that we're interested in. So they've been really helpful, and they're also been extremely helpful with helping my student and grad student and postdoc forecasters, trying to give them some local expertise.
Flying in a winter type of storm, does it present any additional challenges versus like the hurricane hunters who fly in warm core systems?
Well, that's a good question. The two different systems are pretty different. The hurricane hunters typically fly fairly high, and what they're doing is trying to get different profiles of the environment of the hurricane and try to get a good estimate of what the central pressure is. So they're kind of after a different kind of problem, and they fly fairly high, so they're well away from any kind of icing problems. So for us flying in snowstorms in the winter, depending, like this last case, we actually flew, it was rain on the surface, but the structure of the storm was the same. So we flew in it, but icing was an issue that we had to watch out for. I think our main challenge is getting airspace to do the maneuvers that we want to do to sample these storm systems. But so far, the air traffic controls have been extremely helpful and very accommodating. On our first flight, we were kind of messing around in upstate New York and Vermont, but then we wanted to go across Long Island. And when you looked at, there's these, apps called like FlightAware, you can watch where all the airplanes are. They kind of cleared out a corridor and let our plane go through. It was like, oh man, that is very, that was really great of them to do that for us. So that, even though it's challenging but we're trying to do our best to not demand too much and we do whatever they tell us to do.
Is your aircraft on FlightAware? Is it something people can track when you're on these?
Yeah, it is something people can track. Yeah, definitely.
According to the website I found, which is a NASA website, it's November 806 NA and November 809 NA. So
I just couldn't remember where the N and the NA were. So
we like to make it difficult in aviation.
Yeah. So.
Oh.
These airplanes, especially NASA flies a lot. So does NOAA, and my colleagues who get National Science Foundation funds can also request the NOAA or NASA flights, and so they've very experienced crew in field campaigns like this. And each one has its unique way of doing operations. I think. We're not doing anything really clever, fancy, different, and never been done before. And a lot of our instrumentation has been used in many other projects. And in some ways that's good. It's kind of less risky. And we'll get good data right away. And so it's, banking on the experience from other campaigns.
So I know specifically the focus of this project is for snow bands, but does some of this data also feed into freezing rain and sleet forecasts as well?
It might, yes. I think what we're doing at this stage is we're first looking for any storm we can find. The banded structures can result in different things at the surface. The bands form aloft. So at those levels, that's always below freezing. And then the structure at the very lowest levels, the airplanes can't, observe because you're going to crash them because you're flying so close to the surface. So if it happens to be a situation where there's pre-existing, I've told others that, snow bands are our wish list, are the main thing we want to get for. But if the storm happens to be warmer than your usual winter storm, the structures are similar and we can still learn the science of what makes those structures. Why does it organize in these narrow bands that are maybe related to the low pressure center deepening or maybe not. There's different hypotheses that we're testing, and we can test them with a variety of storms, including ones that have freezing rain and things like that.
Lynn, just off the cusp thinking, this may, correct me if I'm wrong, may be able to help predict or maybe forecast where we could actually see those intense bands set up where we see thunder snow. Is that?
Oh, that would be, thanks for mentioning the thunder snow, because for this year on the ER2, we do have an instrument that measures the electric field, which then relates to lightning. So if thunder snow happens to occur, we will actually learn some really fascinating stuff. They've never flown this instrument in situations where in winter storms. So you're correct that one of the applications of the data that we're collecting should help us improve forecasting in a variety of ways. The first way is, we will understand the processes much better. So the science will elevate our knowledge base. But then the direct measurements of those snow crystals and the environment they're forming in, and what the liquid water content, the temperature, all these other parameters, these are things that our numerical models are also predicting. But we have to do that, what we call using microphysical schemes. It's kind of like an algorithm that figures out how to do this. And they're invariably wrong, so that we don't have that portion of our numerical model very well constrained. And by having these direct measurements, we can see which one of these variety of microphysical schemes that you have a choice to use when you run a forecast model, which one is the most correct for these kinds of storms. They make assumptions like how much is made into snowflakes, how much is made into solid ice, how much remains in cloud liquid water. There's those things are assumed in the numerical models, but we will measure those so we can tell the models, no, you're wrong. I don't care how much snowfall comes out of that model. You're still not getting it right for the right reason. So that's one of our key applications, is hopefully down the road making improvements in our numerical models.
What's it like? I mean, this has got to be probably the most difficult part of the research.
Yes, it is. Where it takes us all week to figure out, like, how would we fly this forecast that's 85 hours out. So far, everything's gone great. We've been lucky, but we haven't flown a lot of cases yet. As you know, it's been kind of a quiet winter, but maybe that's a good thing. So we will be back again next year, and we hope for a really active year, and we really know how to go about this. So this is, even if we don't fly a lot this year, we'll have learned a lot. We will have gotten pretty good data, and we're ready for a better year in the next two.
Some of these, ideal winter storms can be quite massive and stretch all the way from the southeast to the northeast.
Right. Mm-hmm.
Is it possible for the planes to cover the southeast on day one and then get to the northeast in time for the deepening low pressure?
We would love to do that. The trouble is that these storms kind of move a little too fast. The way when you work with aircraft, there's a certain amount of time that they can fly because of how much fuel they can take, and also for crew duty. So they're very, very strict with how long a pilot can be operating the plane. The ER2, the one that flies really up here, high, is there's only one person on the plane, and that's the pilot. So, and he wears a spacesuit. He's almost beyond the atmosphere. He's so high up. So he has to, we have to be sure that that person is within the safe range. So total crew duty is 12 hours. That includes the pre-flight routine and then landing and the post-flight routine. And then we are required to give them 12 hours off before we required them to show up again. So if my storm would move really slowly, I could probably do that.
Well, and I know you mentioned that next year, the project's still going to be going on. How
Mhm.
long is it set for at the moment?
We're here now, and we're here to the end of February. And then next year, approximately the same, another 6-week window, we'll be out here in the following year. So 3 winters.
Emergency management. Maybe if they,
Oh, yeah.
we get this research about where these heavier snow bands, like forecasting. Maybe emergency management. That's where they put their assets at. I was just wondering if who all you can see the benefits from this research.
Yes, I can see like the public at large, and of course the emergency management is part of that because they are the communicators from the forecasters to the public, and they kind of make decisions about how to respond to any kind of threat like a snowstorm. So I could see the public being, benefiting a lot in the long run. It's always hard to see the direct benefit. I'm going in, geeking out about the great science I'm doing, but understanding these snowstorms better and then using that understanding to improve our forecasting. And when our forecasting is done better, and especially in terms of the distribution of snow and where those bands occur, and do they set up, and if it's one kind of storm, do we expect to get a lot more of these banded structures and therefore more localized regions of heavy snowfall? Or do we see that, a different kind of storm would not have that, and so there maybe be less of a worry? So yes, indeed, that'll eventually benefit the public, our understanding, and then applying that understanding to better forecasting, and better forecasting will help the managers be able to react in a timely manner to inform the public.
I know it's kind of early into the project.
Mm-hmm.
What's the feedback been like so far?
Thumbs up. It's great. We love it. When the type of instruments we fly on the P3 are kind of finicky and difficult instruments. So some of them have not been operating at the top as they could be. So that's some of the feedback. We're trying to correct some problems or fix an instrument or two. The data that I've been looking at looks really good, I think. What you kind of is exciting is you look at it and go, I don't know what's going on. When you have that kind of reaction, that's actually a good thing, because it means you're going to learn something new. So I'm excited about that. So far, I think everything we've collected really high quality data. We haven't lost anything. Like sometimes, your biggest worry is like somebody forgot to flip the switch and it didn't record. Like, oh no, don't do that. So far, everybody knows what to do. They got all the switches turned on. Everything's good. And so far it looks great. So we just need more storms. That's all I need.
Well, we need some more storms too. We're hoping.
I know. We all need more storms.
We need some more storms too. Well, Lynn, it's been a fantastic discussion. I'm going to go ahead and close out. So everyone, thanks for watching the Carolina Weather Group. We hope you've enjoyed this discussion. Lynn, I want to ask you, if you don't mind, if people want to follow along with the project, I know you have some social media platforms they can follow. How can they do that?
Boy, I should have wrote this down. So the one I know for sure is our Twitter account, which is at snow with a capital S and then impacts, IMPACTS.
Awesome. We follow here on the Carolina Weather Group, and I personally follow the Snow Impacts on Twitter. So get some great information there. You get some behind the scenes photos and things like that. So Lynn, thanks so much for joining us. We want to thank you for watching the Carolina Weather Group, and we will see you on our next episode.